welcome to CEC lectures. Myself Dr. Priti Jagwani. I am an associate professor from Department of Computer Science, Aribhat College, University of Delhi. So today's topic is carrier sense multiple access protocols, which is in short we call them as CSMA protocols. So in the topic of this medium access sublayer, which is MAC sublayer, medium access control sublayer, which is MAC sublayer protocol, we looked into one particular protocol with two of its versions, and the protocol was Aloha. We looked into the pure Aloha and slotted Aloha as well. So, the pure Aloha gave us the efficiency or maximum throughput of 18.4 percentage. Slotted Aloha doubled it to 36.8 or something. So, with slotted Aloha, the best general utilization which we can achieve is 1 upon E, and this low result was actually surprising because so many cautious decisions, cautious mechanism were taken while the stations, although stations were transmitting at will without knowing that what other stations are doing. So, that means this is actually we can say a loophole, or this is actually a gap, because of which there are bound to happen so many collision, because each and every station is transmitting at its own will, and it is not able to, or maybe it is not checking that what other stations are kind of doing. But as far as local area networks are considered, it is often possible for the stations to detect what other stations are doing, whether they are transmitting or kind of not transmitting, and then they can adapt their behavior accordingly. That means if other stations are in transmitting mode, one particular station can kind of have some back off, or if other stations are idle, then some other station can start transmitting. So, that is why this category of protocols is known as CSMA, which is carrier sense multiple access. That means it is having a possibility, it is having a mechanism to sense the carrier, that whether the carrier is actually busy or it is idle. So, with this kind of mechanism, the networks will be able to achieve a much better utilization, a much better throughput than what we got in slotted Aloha, which was 1 by E. And here in this category, we are going to we are going to look into some protocols for improving performances. So, what are these protocols? These protocols are CSMA, then we have CSMA CD, which is collision detection, then we have CSMA CA, which is collision avoidance. So, all these different versions of CSMA protocol we are going to look into. Now, when we say all these protocols are actually carrier sense protocols, because these are the protocols in which the station will listen, or a station is able to listen for a carrier for kind of that medium, whether it is idle or busy, and then they can kind of act accordingly. Now, these CSMA protocols, what are the we can say characteristics of these CSMA protocols? So, the basic characteristics, if we look into these CSMA protocols, work at data link layer, and definitely the idea was to design to reduce the chances of network traffic collision, and hence the communication which we are looking for should be kind of smoother and more efficient utilization or maximum utilization of a carrier or that channel should be done. In order to do that, these protocols are having the mechanism of checking the medium before transmitting, and devices using CSMA will definitely improve the overall network performance, because the previous protocols which we looked into, pure Aloha and slotted Aloha, have no mechanism of looking into the medium, looking into the channel, that whether these channels are idle or busy, and then there was kind of we can say high chances of collision. Here those chances of collision will kind of we can say definitely be reduced, we can say. So, carrier sense multiple access, which is CSMA. Basically, it is a method which is used in computer networks to help the devices share a communication channel without interfering with each other. Why they are kind of able to do it without interfering? Because they are sensing the network, they are sensing the channel, we can say, or the sensing the medium, and before a device sends, it listens to the channel, or in other words we can say it sends the carrier in order to check whether your carrier or whether your channel is free or not. And if the channel is busy, the device will wait until it becomes idle. So, what is the advantage of this sensing mechanism? So, because of this sensing mechanism, data collisions are prevented. These data collisions were bound to happen, or were kind of we can say happening in a huge amount when two devices try to send the data at the same time. Now, looking into the application area, your CSMA is widely used in networking technologies like Ethernet and Wi-Fi also. Now, there can be kind of so many versions of CSMA. If we look into, we have persistent and non-persistent CSMAs. We will also look into its type, which are CSMA CD and CSMA CA. Definitely, we are going to cover that in our upcoming lectures in detail. If we look into persistent and non-persistent CSMA, the first carrier sense protocol here we called it as one persistent CSMA. So, this one persistent CSMA, let us try to understand what actually is this. So, when a station is having, when a node is having a data or a packet to send, it first listens to the channel to see if any other node or if anyone else is transmitting at that particular moment. If the channel is idle, the station sends its data. Otherwise, if the channel is busy, the station just waits until it becomes idle. Now, how your node is going to determine that whether the station or whether the channel has become idle or it is still busy, that is the fact, or that is the kind of we can say point which is going to differentiate between persistent and non-persistent CSMAs. So, then the station transmits a frame if it is having kind of a free we can say channel is free. Even then, if a collision occurs, the station waits for a random amount of time and starts all over again. Now, this protocol, if we look into detail, is called one persistent CSMA because the station is transmitting with a probability of 1 when wherever or when it finds the channel idle. Obviously, when the channel is busy, your station is not transmitting, and it is only transmitting when the station is when the channel is idle with the probability of 1. And it seems that the scheme try to avoid collision except for the rare cases of simultaneous we can say sends, but in fact it does not. If two, now see what is actually happening in the reality scenarios. If two stations become ready in the middle of a third station's transmit, so A is already transmitting, B and C both are ready with their own transmissions, and they sense the they try sensing the carrier. They both find the carrier as busy, and then they will wait. They will wait politely until the transmission end, and then they will kind of sense the channel again, and then what will happen? They both will start their transmission. It may happen that they both will start their transmission exactly simultaneously, and then as a result we will have collisions again. If they were not so impatient, that means they are waiting till the transmission of A is ending, and then maybe some more amount of time after that. If they were not so impatient, there will be fewer collision, but if these stations are impatient, collisions are bound to happen. Now, please recall, that in peer aloha I explained one concept which is known as, or one point which is known as vulnerable time. So here if we look into the concept of vulnerable time in context of SASMA, let us kind of have a quick recap that what is this vulnerable time. So vulnerable time, it's kind of a window, maybe short or larger, in which there is a risk of collision between two devices which are trying to send the data onto the network, obviously at the same time, then only there are the chances of collision. So that particular window is in which there are chances of collision, that is known as vulnerable time. So this vulnerable time window, more the shorter window, higher the kind of we can say throughput. Vulnerable time, large vulnerable time obviously is going to results in the less throughputs. In SASMA based networks like Ethernet and Wi-Fi, each device listens to the channel before the transmission. If the channel seems free, the device waits a tiny moment and then begins sending. However, another device, there is a possibility that another device might also sense the channel at the same time. At the same time, that means when it was free, and then they both may start transmitting at simultaneous point of time, or within, I can say, within the vulnerable window, and definitely it is going to cause a collision. This is small time window where such collision can still happens even after sensing, or it's not like that stations are not sensing, but what if two stations are sensing at the same time? So even after sensing, the collision can still happen, and this window or is actually the vulnerable time. Now here if you can see, we have 4 stations, and these stations are A, B, C, D. Now let us say one particular station starts transmitting, then B and C both senses the carrier at some particular point of time, which is being kind of uh, uh, we can say shown here with the help of dotted lines. So B has kind of sensed and C has sensed, and if a transmission is already going on, they both got the channel as busy. Obviously they will not kind of we can say start, but after kind of patiently hearing for this channel to be uh, free, definitely they are going to kind of sense definitely they are going to sense again, and then they begin the transmission one at a time. So here that's why we have shown that vulnerable time is equals to propagation time, and then D may kind of sense after completion of one particular transmission. That also can kind of we can say happen. So this is what the depiction of vulnerable time is in case of this protocol if we talk about. Now if we look into, I was talking about so many modes and so many types of SASMA. If we look into the types of SASMA access modes, there are 4 types of access modes which are available in SASMA, and it is also referred to as 4 different types of SASMA protocols which decides the time to start sending the data across obviously a shared media, or we can say a shared channel. What are these 4 different types? These are 1 persistent, non persistent, P persistent and 0 persistent. Let us try to look into all these modes one by one. So if we look into 1 persistent, it sends the shared channel first and delivers the data right away if the channel is idle, and this is what this 1 persistent mode is what we have covered just now in detail. Now if not, that means if the channel is not free, the stations are waiting and continuously tracking for the channel to become idle, and then broadcast the frame without condition as soon as it does. So kind of when we can say an aggressive transmission algorithm, that means the channel is being continuously tracked, the channel is being continuously sensed. As and when the channel is becoming idle, the frame is being broadcast without without looking without looking here and there, without any condition, as soon as it does. So this is the mode which is persistent. Now, one persistent, more specifically, if we talk about looking into the next mode, which is non-persistent. So, non-persistent mode or non-persistent type of CSMA protocol first access the channel before transmitting the data. If the channel is idle, obviously the node transmits the data right away. That is what the, we can say, correct decision to implement. If not, the station must wait for an arbitrary amount of time, and it is not tracking the, kind of sensing the channel continuously, and when it discovers that channel is empty, it sends the frame. So, this is, we can say, it is not the kind of very kind of aggressive transmission technique or transmission protocol, because it wait for an arbitrary amount of time. It is not like that it is kind of tracking or it is sensing continuously, and the moment it is going to kind of get a chance, it is going to grab the channel. It is not like that. The channel, the stations are waiting for an arbitrary amount of time, not continuously tracking the channel, and whenever they discover that the channel is empty, they send their frames. So, now we looked into two modes of your CSMA, which is one persistent and non-persistent. Moving on to the next one, which is the P persistent. It consists, we can say, a combination of these two modes, which are one persistent and non-persistent. So, both the modes are combined in order to have this P persistent. So, what is happening here? Each node observes the channel in the one persistent mode, and if the channel is idle, it sends a frame with a P probability. If the data is not transferred, the frame restarts with the following time slot after waiting for a probability, which is q is equals to 1 minus p, and that is nothing but a random period. So, how this P persistent is actually combining the two modes, which are one persistent and non-persistent. So, each node observes the channel. In observation of channel is being done in one persistent mode. If it is idle, the frames are sent right away, but with a probability p. If the data is not transferred, the other part of the probability is obviously going to 1 minus p, and then the frame restarts with the following time slots after waiting for q is equals to 1 minus p probability, which is a random period. So, hence we can say both the kind of one persistent and non-persistent modes are combined in order to have the mechanism of this P persistence. So, persistence is there, but with a probability, or kind of frames are being sent with a probability of P, not with the probability of 1. Then there comes zero persistent, which is in which a supervisory node gives each node a transmission order, and nodes wait for their time slot according to their allocated transmission sequence when the transmission medium is idle. So, this essentially means that even if your transmission medium is idle, nodes need to wait for their time slots according to their allocated transmission sequence. This give me remembrance about our kind of topology, which was ring topology, and each and every node or each and every station is having their turn, and that turn is determined by whosoever is having that token, and then that token keeps on passing on that particular ring. So, this give me remembrance about the uh, uh, ring topology, which is here zero persistent, in which who is going to give the transmission order, or who is going to assign the transmission sequence. It is obviously one supervisory node, and nodes will wait for their time slots according to their allocated sequence, if even if the transmission medium is idle. Now, if we look into different types of CSMA protocols. So, the 4 versions of CSMA protocol we have seen, which were actually one persistent, then we look into the non-persistent, P persistent was there, and then there was 0 persistent. Now, if we look into how many types of these CSMA protocols are there, so there are kind of mainly two types of CSMA protocols. Each of them is designed to handle how the devices manage the potential data collision on a shared communication channel. So, now please try to understand the difference between this type of CSMA protocols when we talk about their types as CSMA CA and CSMA CD versus what we did just, which was kind of different access modes. So, CSMA types, there are two types which are CSMA CD and CSMA CA, but if we talk about the modes in which it is basically about how they sense the channel and how they are going to kind of transmit the how aggressively they are going to transmit the frame. So, that categorization falls under the modes which are 1 persistent, non-persistent, P persistent and the 0 persistent. Now, if we look into the types of CSMA protocols, the types actually comes here, that how the data collisions are going to be handled on a shared communication channel. So, even after these kind of cautious measures that kind of nodes are sensing the channel, and then they are kind of going to begin the transmission, maybe after a random amount of kind of back of time, there are chances of collisions. So, how these collisions are going to be handled, this mechanism is going to give us kind of two different, we can say, types of CSMA protocols, and these types basically differed based on how they respond to the detection of a busy network. What are these two types? So, these two types are CSMA CA, and how are we going to write it? That is CSMA/CA. So, CA here stands for collision avoidance, and then CSMA CD, which is CSMA/CD. So, CD here is collision detection. So, one protocol, we can say kind of these two protocols actually differed in their kind of proactivity. So, one is kind of trying to detect the collision. Obviously, they are going to detect the collision after the collision happens, and then they kind of work accordingly, they work for the damage control. So, this is your CSMA CD, but if we talk about CSMA CA, which is collision avoidance, this is more kind of a proactive protocol which is trying to avoid the collision by adopting some mechanism for avoidance. So, one is trying to detect the collision. Obviously, detection happens after the occurrence, wherever the avoidance happens before the occurrence. So, these two types of CSMA protocols definitely differ in how they respond to the detection of busy network. So, in this lecture, if we looked into, we have quickly recapped our slotted Aloha and begin with the carrier sense multiple access CSMA protocol, which is basically there in order to reduce the chances of network traffic collision, because it sends the medium, it checks the medium before the transmission. Then we looked into the different modes which are obviously after understanding the mechanism of this CSMA, we looked into the different modes which are kind of four modes, which is 1 persistent, 0 persistent, then P persistent and non-persistent. We looked into the vulnerable time in CSMA, and definitely we laid down the foundation for our upcoming lectures by looking into the types of CSMA protocols, which are CSMA CA collision avoidance and CSMA CD, which is collision detection. Here is a list of references which is being used for the preparation of lecture. In the upcoming lectures, we will be looking into these types of CSMA protocols which we just kind of briefly described. Till then, take care, goodbye, I will see you in the next one.